Hey, Matt, I came back to class and they informed me that you went home. I hope you get to feeling better. We are going to do some notes from 4-5. I don't know, a little bit here. It's a lot of examples. Like, there's a lot of examples on 4-5, and that's basically all it is examples. But it's all like using logs and exponentials, kind of like with algebra to just solve these things, okay? So the deal here is 4-5, like looking at example 1. This is an exponential function, right? He is in EXP land, and we have 7 as a base and 12 as a base. And typically in the past, what we would like to do is we would like to like switch them to be the same base. Like if this was 3 to the x power equals 9, like I could change this 9 to be 3 to the second power, and then the 3's would cancel, and then x equals 2. Like that's how it would be in the past. But 7 and 12, that is not possible to create them to be the same base because 7 is prime, so that doesn't work. So how the heck do we even do this?
Okay. Turn it into a log.
Yeah, turn it into a log. So we could switch it to a log function and have like log, so don't write this down, but we can make it like log base 7 of 12 equals x. Like we could do it that way and make it a log function, but my calculator doesn't think in log base 7, right? So what we could do, yours maybe does, right? So that would be okay. But what we do instead is we put a log in front of both sides. And that log is log base 10, right? Okay, and if I put a log in front of both sides, then this x can come down in front. So what I have is x times log base 10 of 7 equals log base 10 of 12, right? And then how do I get x by itself?
Divide by log 7.
Divide by log 7. Now, just FYI, I'm going to do log 12 divided by log 7. If I try to take this guy and change him to a base of 10, doesn't this become log 12 over log 7?
Yep.
Like that guy? So, I mean, you can think about it in terms of that. Log 12 divided by log 7, what does that end up being?
1.28.
Go 4 decimal places.
Okay. 1.278. Nope. 77.
7, 2777.
That's not what I got.
No, what'd you get?
1.2770.
770.
Ellie, what
Yeah.
else is wrong?
Yeah. Yeah.
1.277 be 10. So yeah, he's right.
Yeah. 2770.
Something
Okay,
like
we
that.
got it. We got it.
I'm used to 3 sig figs, and that's
I
how
know.
far
I know.
can
They
get.
want you to go 4 decimal places. Give the solution to the nearest thousandth. Oh, thousandth
three.
is actually 3. Shoot.
I was right.
Usually they have you do 4 decimal places. So I'll just say 4 decimal places. How about
No,
that?
it's still 7.
Yeah, it's still 7. So anyway, you log both sides. Now we could have, if we wanted to, instead of logging both sides, we could ln both sides, right? And then it would be ln of 12 over ln of 7. But same thing. You're going to end up with the same thing, okay? All right, now here is a little bit messier. Our bases are 3 and 0.4. I cannot get those to be the same base because they're disgusting. But we are still in exponential land. So what we're going to do is we're either going to log or ln both sides, and we're going to do all the algebra, all right?
Log.
You want to log both sides? Sure. So I have log and I have log. Okay, great. I have log of 3 and I have a log of 0.4. Now what do I do?
Back things to the front.
Can we bring all the back things to the front? Absolutely. So this 2x minus 1 comes down in front, and this x plus 2 comes down in front. Okay? So 2x minus 1, he's down in front, times log base 10 of 3 equals x plus 2 comes down in front times log base 10 of 0.4. Right? Like that's what he looks like. Okay, now what?
Can we move our logs to one side?
Can we? Sure, we can. I mean, yeah. So, like, let's say we want to put the logs together because, like, this is an ugly decimal and this is an ugly decimal. So if we can combine them together somehow and just make 1 decimal instead of 2 ugly decimals, that would be the best. So do you want to move the 3 to the 4 or the 4 to the 3?
4 to the 3.
You want to move this guy over here? How do I move him over there? Divide. He is being multiplied. So I'm going to divide by log of 0.4. Okay.
Move the x over at the same time.
And divide. No, we can't do that yet.
You can't?
No. Divide by log of 0.4. Okay, so this guy's just chilling. This is 2x minus 1 times, and then give me this as a decimal. What's log 3 divided by log 0.4?
Negative 1.1. Negative 1.199.
Go 4 decimal places.
Ah.
208.
9-8. Should be that way, though.
1.19.
90.
990. Yeah, 990. Okay, that's fine. All right, now what do we do? We're in algebra. This is all algebra.
Okay, hold on.
Divide the 2x.
We need to put the factor it through.
Yeah, we got to distribute this guy through, right? This guy's got to go through because he's multiplied. Yeah, so take him times 2. Whatever you have right there, take him times 2.
Negative 2.398.
0.
6.
8, 6. Yeah. X.
7. Wait. I don't know.
Wait, it's 0.308.
What are we doing
I
here?
don't
You're
know.
getting too many 9s and it's confusion.
2.3979. So that would be a 0, and so that would be 80.
See, I
Yeah,
said
you're
it
right. You're right. Yeah, there we go. Okay, and now we'll have an X on him. Okay, now this one. What if you take him times -1?
Plus.
Positive that 1.91 whatever plus 1.1990 equals X plus 2.
Subtract that 1.199.
Yep, I like it. Minus the 1.1990.
Minus that X.
Okay, minus 1.1990. And I'm going to minus the X to this side. Okay, so what's that give you if you subtract the X?
Well, it's going to be 0.801 on the...
0.801 equals 0.801. 0. Okay, and then what's this? What happens
that
here?
number, right?
What happens here?
The X go away?
No, the X's don't go away.
Just minus 1. So,
Negative. They're both negative though.
oh, positive.
3.3980 X, right? This is -2 minus another 1, right? You see how that works?
Then we got to divide that.
And then we just divide him. Divide by -3.3980 divided by -3.3980. And X is a big, long, ugly decimal that's negative.
Wait, why are you going that way with the X?
Because you got to get the X by itself. The X is on the right, on the left. X is -0.
2357.
0.2357.
Yep.
Perfect. There we go. That's what we got. Okay. The algebra is just like
That's a lot of...
algebra 1 stuff, but with ugly decimals. And it's like, oh crap, I can't see what to do because this decimal's in the way. So don't get distracted by the decimal. It's just math. It's just algebra. But there is that, okay? So, as disgusting as that is, there you go. All right, now these are the fun ones, I feel like. I always like using ln better than log. I'm just that way. I don't know. Okay, are we ready? Solve each equation. No? You want me to wait for you? Yeah? Okay. Hold on a freckle. It is really hot right now. I'm blowing on it. And this coffee's been sitting there since like this morning. So I don't know why it's still hot. Their heater must just be real hot. Okay. All right, we've got an A and a B and all the things. All right, A.
L on both sides.
Yeah, we want to ln both sides because it involves an E. And guess what happens to ln and E?
They cancel.
Boop.
So we have X.
X squared equals, and what is ln of 200?
Probably 200.
5.29.
83.
83. 5.2983. Okay.
Take the square root of that.
Take the square root of that. And X is 2 point something.
302.
2.302. And we need
Plus and minus.
plus and minus. Because we put the square root in, right? Ha 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 ha.
Why can't they all be easy like that?
Okay. All right. Here we go. Oofda.
Can we combine them?
Can we combine these two on this side? What do? You need to add the the exponents, right? Like x squared times x cubed, you would add those exponents, right? Okay, it's the same thing with the e, right? So I can combine this 2x and this negative 4x, so you're right, e to the negative 2x plus 1 equals 3e. Okay,
Now ln.
yeah, now we ln. This is gross, because that 3 is there.
3 back first,
Now we can't because it's not an ln though.
but then we can ln it, and then the e's cancel, so then it's just 3 equals.
Wait, does the ln and then the e cancel?
This ln and e won't cancel.
So it's not an exponent?
Yeah, but that's okay. That's okay. That'll just be a decimal over there. So ln and e can cancel over here to make this negative 2x plus 1. True? Equals, what's ln of 3e if you type that into your calculator? Ln of 3e if you need to put them in parentheses. So it would be like that.
E button?
Right next to the ln. Should be.
It's e to the exponent?
Yes, yes.
But then what do I put in for the exponent?
1.
Times 3?
Let me see.
I got like 2.00986.
2.0986.
Okay. Okay. You don't want ln of 1. You want ln of, where's your e button?
It's the square.
Yeah, yours.
Oh.
Yeah, you got to put an exponent in there. So it'd just be like ln of 3e to the
I don't
first power.
think I put the
2.08 or 0986. Is that right? 2.0986. Okay. And then what? Now it's math. Now it's algebra. Minus 1. Negative 2x equals 1.0986. And then we divide by negative 2, and that's it. And somebody's got to give me that.
0.5493.
0.5493. Perfect. Thanks. Now, I would, if I were you, and I think most of you guys are really good about doing this, like as you go through here, don't retype any decimal numbers. Use the full decimal as you go through, right? Like you just keep adding to that number, right? And subtracting from that number and multiplying by that number and all the things, right? Because then your final answer will be the most accurate. So don't try to retype any of the decimal numbers if you can help it. Okay? Good?
One more.
Oofda. All right. Okay, this is interesting. This is interesting. You don't see a whole lot of these. I don't think I give you a whole lot of these, but here's the deal. All right, we are going to pretend. You ready? We're going to pretend. We're going to pretend for right now. E to the x is going to be,
1.
let's call it y.
Okay.
Let's replace it with y, right? Okay? So I'm going to take all the e to the x's in here, and I'm going to replace them with y, right? Okay? So like this plus 3 is just chilling. What does this become?
4y.
Negative 4y, right? Okay, what about this, where it's e to the 2x?
2y.
The e to the x is going to cancel out and be y, right? That will become y squared, right? So now this is a quadratic function. We have y squared minus 4y plus 3 equals 0. Okay, now what do we do with that? What? You mean the x up here? So if we pretend that e to the x is y, e to the x will cancel and make y, but that'll just still be y squared. Okay, so now we have a quadratic, right? What do we do with that? Y squared minus 4y plus 3. That's a simple trinomial, right? What can you multiply to get 3, but when you add them, give you negative 4?
3 and 1.
Yeah, negative 3 and negative 1, right? Yeah. Okay, equals 0. Now, at this point, here's what I would do, right? I would say that y minus 3 equals 0 and y minus 1 equals 0, right? That's what I would do next, okay? But here's the deal. And then I would say that y equals y equals 3 and y equals 1, right? Like that's how I would do that, right? And those would be my two answers. Do we see how we get there from there?
So we can
Right?
just forget.
But the deal here is, no, just wait. Okay, do we see how we get to there from there?
Yeah.
Right? But y is not y. Y is e to the x power, right? And e to the x power, okay? So if I'm trying to solve this guy over here, how do I get x down out of there? Yeah, let's ln both sides, right? So ln and e are going to cancel on ln of 3. So x is equal to ln of 3, which is something.
1.0986.
Perfect, okay? And I do the same thing over here. I'm going to ln both sides. That's going to cancel. So x is equal to ln of 1,
Which is 0. Right?
which is 0. Yeah. Those are my two answers. Okay, so we just make him look nicer, and then we just replace him back in after we factored him down. You don't see a whole lot of those. That was kind of like a, oh, how do I think to do that on my own? Well, it's just kind of a weird wonky donkey thing. Okay.
That's it for today.
You think we've done enough for today?
Yes, I'm snowed.
You're snowed.
We do a page each
Okay.
day.
Okay. I'll go. What time do we get out of here? I will go run off homework. Ooh. I'll go run off homework so I can give it to you.
8 minutes.
Okay. All right. Bye, Matthew.